My name is Juliet Hartman, and this is my project for the Georgia Institute of Technology, Design and Manufacturing ME 3210 class. Project 1 focuses on important manufacturing topics for better engineering, and this will be submitted to Dr. Hassan Rashidi. The 5 topics I'd like to share today that I believe will lead to designing and manufacturing better products are 1. Environmentally conscious design, 2. Casting, 3. Welding, 4. Product lifecycle management, also known as PLM, and 5. The Kano model. Environmentally conscious design, also known as sustainable design, focuses on minimizing environmental impact throughout a product's lifecycle, from raw material extraction to disposal. It involves eco-friendly materials, energy-efficient processes, and sustainable end-of-life strategies such as recycling or biodegradability. Applications include eco-friendly consumer products, green buildings and infrastructure, automotive and aerospace vehicles, and the electronics industry. The importance of sustainable design is that it reduces carbon footprint and resource depletion, it helps to meet environmental regulations, it enhances brand reputation and consumer appeal, and it encourages innovation in sustainable materials and technologies. Capabilities include reduction of waste and lower energy consumption, improvement in the long-term cost efficiency by reducing material and disposal costs, and promoting compliance with strict environmental laws. Some of the limitations, however, include high initial costs due to sustainable materials R&D, limited material availability for higher performance applications, and consumer resistance to higher priced sustainable products. The Kendeda building is a product of environmentally conscious design. The photovoltaic canopy supplies 225% of the building's energy needs on an annual basis. The canopy also stores water from rainwater in a 50,000-gallon cistern in the basement before being treated and used for all purposes, including drinking water. It's composed of materials that are screened to ensure the absence of hazardous red list chemicals, and its composting toilets nearly eliminate potable water use for sewage conveyance and allows for human waste to be turned into fertilizer for use off-site. Now for casting. Casting is a manufacturing process where molten metal or plastic is poured into a mold and solidified into a specific shape. It enables the production of complex and high-strength components with minimal machining. There are many applications of casting across the automotive and aerospace industry, construction, medical equipment, industrial equipment, and even art and jewelry. The importance of casting is that it enables mass production with minimal material wastage, it reduces machining operations, which lowers overall production costs, and it allows for the recycling of scrap metals, making it a more sustainable method of manufacturing. Capabilities of casting include cost effectiveness for high volume production, it produces intricate near-net shaped parts, it can use recycled metals, making it eco-friendly, and it supports large and heavy component manufacturing. Some of the limitations of casting include that it is an energy-intensive process due to high melting temperatures, casting defects such as porosity, shrinkage, and residual stresses can require secondary processing, and there is limited control over material properties when compared to forging or machining processes. A case study for casting includes Tesla's single-body casting process, also known as the Giga casting process. It's a groundbreaking manufacturing method that eliminates multiple welded or bolted parts in favor of a single massive die-cast structure. This innovation significantly reduces production complexity, weight, and cost while improving vehicle performance. Molten aluminum alloy is injected into a high-pressure mold, rapidly forming a strong, lightweight structure. The liquid aluminum cools in seconds, solidifying into the desired structural shape. The cast part is then ejected, trimmed, and inspected for quality. The casting undergoes heat treatment for increased strength and durability. Welding. Welding is a process that joins materials, mostly metals, using heat, pressure, or both. It is essential in fabrication, construction, or repair industries. Typically, when we think of welding, we think of traditional TIG, MIG, or stick welding, where a plasma arc is used to melt the metal, which will re-solidify to join different pieces into one solid piece. There are other types of welding, however, including laser, cold metal transfer, or friction stir welding. Welding is an important manufacturing method across a multitude of industries. including shipbuilding and offshore structures, bridges and high-rise buildings, the automotive and aerospace industries, and pipeline and pressure vessel industries. The importance of welding is that it provides a strong and durable joint with minimal weight increase, it reduces material waste compared to bolts or rivets, and enables fabrication of large and complex structures. The capabilities of welding are that it's stronger joints than mechanical faceting, it is a lightweight design without added fasteners, it allows automation with the increase in robotic welding, and can use sustainable materials and methods. Some of the limitations of welding, however, are that it can emit hazardous fumes requiring ventilation and PPE, it has high energy consumption in certain welding techniques, and material distortion and residual stresses can exist in high heat applications. An example for the importance of welding is that I did CMT research while I was an intern at NASA. So I spent my time programming and operating a robotic welding tool where I investigated reducing the porosity of the welds and improving material properties in a CMT process. This will eventually be used to make spacecraft. Next, there is product lifecycle management, also known as PLM, which is a strategic approach to managing a product's lifecycle from conception to disposal. It integrates design, manufacturing, and recycling data to enhance efficiency and sustainability. It has applications across many of the same industries we've talked about before. In the aerospace and automotive industry, it can track components and materials across supply chains. In electronics, it can manage modular designs for repairability and recyclability. For medical devices, it can ensure compliance with FDA and ISO safety standards. And for energy and utilities, it can manage the life cycle of wind turbines, solar panels, and batteries. The importance of PLM is that it reduces environmental impact through life cycle assessment, it enhances traceability and compliance with environmental regulations, and it enables predictive maintenance while reducing unexpected failures and waste. Capabilities of PLM include it improves sustainability by optimizing material use and reducing waste, it supports the circular economy model, reuse, refurbish, and recycle, it enhances collaboration across global supply chains, and it improves data-driven decision-making. Some of the limitations of PLM include that it requires a high initial investment in software and training, it can include complex integration with existing manufacturing processes, and it is difficult to standardize across industries. The last topic I would like to cover is the Kano model, which is a customer satisfaction framework developed by Professor Nokori Kano in the 1980s. It helps an organization understand how different product features influence customer satisfaction, and it prioritizes design elements accordingly. Such applications include product development, user experience design, marketing and brand strategy, it enhances the service industry, and it also is integrated with software and technology development. The importance of the Kano model is that it helps prioritize product features for maximum customer satisfaction. It distinguishes between necessities and delighters, improving resource allocation. It aids in competitive differentiation by identifying innovation opportunities, and it reduces feature bloat by avoiding unnecessary development efforts. Lastly, it enhances customer loyalty by addressing what truly matters to the customer. For a deeper look at the model, it includes the basic needs, or the must-haves from the customer, and these are essential features that the customer may expect. It includes performance needs, which are features that increase satisfaction as they improve. It includes excitement needs, or delighters, which are unexpected features that wow customers. There are also indifferent features, which are features that neither add value nor cause dissatisfaction, and there are reverse features, which are features that some customers like but others dislike. Capabilities of the model include that it is effective in customer-centered design, as it helps align product features with user expectations. It improves competitive advantage, as it enables companies to differentiate their products. It enhances cost efficiency, as it helps allocate resources to the most impactful features. And it provides a long-term view, which adapts to changing customer preferences. Some of the limitations of the model include that it is subjective to interpretation, as customers may not always know what they want. Market dynamics change, and features that once delighted customers will become expected over time. There is survey and data collection complexity, which requires extensive customer feedback, which may not always be available. And lastly, it doesn't address implementation challenges. Knowing what customers want is different from being able to build it cost effectively. In conclusion, these are the 5 topics that I believe are extremely relevant and will be useful to helping me, as an engineer, design and manufacture better products.